Hi there, we're going to be doing some exponents today. First we're going to start with this. It is x squared times x cubed. So you're looking at a multiplication problem here, and hopefully you're understanding what this really means in the representation of it. X squared could be represented as x times x, x cubed, x. There you go. And if you look at that, it is a multiplication problem. Everything's being multiplied together there. Well, how many x's do you have? It is x to the fifth. Don't get that confused with 5x, please. Something very similar but totally different. X squared to the third. Hopefully you're understanding what this exponent means. That exponent of 3 means that it is x squared times x squared times x squared 3 times. So really you're looking at this. And it is a multiplication problem. Well, there's the expanded version, and very similar to what we did over here, that would give us x to the sixth. So it is the difference when you are multiplying. You add your exponents. A power to a power. You will multiply those exponents. Let's take a look at this. 3x squared, well, that is 3x squared. Different from 3x quantity squared. Well, what this is, it is actually 3x times 3x, giving me 9x squared. Let's give us a little break right there. Or, what about negative 3x squared? Well, what is being squared? Simply what is inside these parentheses, so this could be expanded to negative times 3x times 3x, giving you then negative 9x squared. Now let's take a look at some division. Saying we have, let's say, x to the fifth over x squared. Well, your top, your numerator, your denominator. Okay, so 2 of these x's on the top cancel with 2 of those x's on the bottom, leaving you simply with x cubed in the numerator. Similar to this, same expansion, but really reversed. So those cancel, and you have x cubed. But be careful, that x cubed is in your denominator. Be sure to signify that it is in the denominator. Well, what is up top? Each one of these that cancels leaves a 1 in its place, so it would be 1 over x cubed. That is a very common mistake that students make, giving an answer of x cubed when it is 1 over x cubed. Be careful there. Well, what if those numbers get larger? X to the 90th over x to the 10th. I definitely don't want to write out 90 x's and then 10 x's. That's just going to take way too long. So what was the process here? Well, 5 minus 2 is 3. Okay, there are more x's up top, so your answer goes up top. Okay, let's see here. It is 5 minus 2 is 3, so it is x cubed. But hey, there's more x's on the bottom, so make sure those x's appear on the bottom. Same type approach. This could be x to the 90 minus 10 equals x to the 80th. I have more x's up top, so make sure I have my x's left up top. Okay, that leads us into hopefully a good understanding of what this is. Let's say we have x to the 10th over x to the 10th. Hopefully you're looking at that and you're saying 1. I know that's 1. 1. Anything over itself is 1, and you would be totally 100% correct right there. Anything over itself is 1. Well, what if we take our properties of the exponents that we just learned? Okay, it is a division problem, so we could subtract those exponents, so it would be x to the 10th minus 10 equals x to the 0. Those are the same thing right there. So that really leads us to this. X to the 0 is 1. anything to the 0 power. Anything to the 0 power is 1 because of this idea right here that is represented. Okay, now let's deal with some negative exponents. X to the negative second, I will slide that up there, make some room, get everything nice and neat. Perfect. Okay, the way that you change a negative exponent to a positive exponent is to change its location. Move it from bottom to top or top to bottom. So this right here is in my numerator. If I want to make it positive, I need to move it from the numerator down to the denominator. There you go. Well, is there anything left in its place? Sure, there is a 1. So that negative exponent became positive by switching its location. You can have things like this, 2 over x to the negative third. Well, this 2 is a positive exponent, so it stays where it's at. This has a negative exponent. So if you would like to make this a positive exponent, let's change its location. Let's move it from the bottom up to the top. You would get x to the positive third, and you'd have 1 downstairs, which is just simply 2x cubed. What about 9, x to the negative second, y cubed, over 16, x to the fifth, y to the negative fourth. Okay, looking at that, we're going to be doing some simplifying. I will hopefully simplify the 9 and the 16. Looking at that, nope, not going to simplify there, so those are going to stay where they are at. And they have positive exponents. Well, let's deal with this x to the negative second. To make it positive, we need to change its location, so it will then come downstairs. X to the positive second. What about my x to the fifth down here? Well, that is positive, so it stays exactly where it is at. Y cubed is positive, so it stays in the numerator. Y to the negative fourth is negative. Okay, so to make this exponent positive, I'm going to take this whole thing and it will come up to the top, y to the positive fourth. Then we apply some of those rules of exponents that we learned earlier. You would get 9 y to the 7th over 16 x to the 7th. Nothing cancels. There you go. That is a simplified version. Do one more of these here. All right, there we go. First of all, I'm going to clean up everything that I can clean up inside this parentheses, and then I'm going to deal with this. So 5x to the negative second, y cubed, z to the fourth, 25x cubed, y to the negative second, z to the 8th. So I'm going to simplify the 5 and the 25. I'm going to give myself a new fraction right there. 5 and 25 reduces to 1 over 5. Those are gone. X to the negative second will become positive by moving it downstairs. X cubed is downstairs in the denominator, so that's where it stays. Y cubed is positive, so it will stay where it's at. Y to the negative second becomes positive by changing its location, coming up. Z to the fourth stays, and Z to the 8th will stay, so we might as well go right ahead and reduce these here. So 4 of these Z's will cancel with 4 of those Z's, so I will have Z to the fourth left, but that is left downstairs. And this whole thing is to the negative second still. Now let's simplify and keep cleaning up in there. I will get y to the fifth over 5, x to the fifth, z to the fourth, all to the negative second. Now this exponent will be applied to everything in there. So everything inside is going to get a negative exponent. First, I'm just going to deal simply with the negative component. If everything in there gets the negative, well then everything in there will change location. So that means this whole fraction will flip, and you will end up with 5x to the fourth, z to the fourth, over y to the fifth. And now my exponent becomes a positive 2. Now everything inside gets squared. 25. X to the 8th is now multiplication. Z to the 8th over y to the 10th. One more little thing that we will talk about. We will now talk about a fractional exponent. Let's say x to the 2/3. Okay, when you're looking at x to the 2/3, that is a root. Your fractional exponents are roots. So the denominator is the root you're taking. It will be the cubed root of, and the numerator becomes the power on this, of x squared. You could have something like this. Excuse me. New example. 9 to the 1/2 power. Well, that is the second root, the square root of 9 to the first. So here's how it would look. The second root, just for visual purposes, of 9 to the first. Well, that is the square root of 9, which is actually 3. Y to the 4/7 would be the seventh root, the denominator out front, of y to the 4th. There you go. Hope that helps. See you around.